Continuing on our discussion of matrices, we have the idea of equal matrices. And two matrices are equal if we have two things going on. First of all, they have to have the same dimensions. So the dimensions, the size of the matrices have to be the same. And secondly, all corresponding elements are equal. So by corresponding elements, those are the numbers that match, that are in the same spots, they all have to be equal. So it kind of makes sense. It's a good definition for equal matrices because it's probably what you would expect it to be. 3 examples here, and we're going to see if each pair of matrices are equal. On the first pair right here, they definitely have the same dimensions. That's good. Now we need to see if the matching elements are equal. And it's all the same numbers, but they're jumbled up. So the 2 matches with the 2, which is good. This is supposed to equal this. It does not. They are not equal. So, because even though they're the same numbers, they have to be in the same spots as well. On the second example, they're not even the same dimensions. We have a 2 by 1 here, and we have a 1 by 2 here. These are not equal matrices. And this third problem here, at first glance, it's like, no, those are definitely not the same thing. But the dimensions are the same. There's a 1, 2 by 2, and 2 by 2. Even though there's a couple terms here, that's all one element. That's all one element right here. At first glance, it looks like, no, they're not equal. But let's actually do the math on these. This is really a -4 here. This is a 0.25. This is a 5. This is a -7. We got -4. We got 5. We got 0.25. That's 1 minus 8, which is -7. Those actually are equal, even though they didn't look like it. They don't have to actually look the same, but they have to be equal when you actually compute them. So those are equal matrices. We can use this new term of an equal matrix to solve for missing elements in a matrix equation. So in this problem, I know that these two matrices are equal. It says so right there. These are equal matrices. And notice the -3's match, the 2's match. But here we have an x and a y that we have to solve for. Well, I know that these two circled purple things have to be the same. The matrices are equal, so those have to match. That means that this guy, x plus 1, has to equal 4. And now I'm just solving a quick algebra problem. I get x equals 3. By the same token, I know that these bottom right guys in orange here have to match. The matrices are equal, so those have to be the same thing. So 5y has to equal 12, and if you divide both sides by 5, you get y equals 2.4. That has to be true. On my last example here, I'm adding two matrices and getting an answer. So if you look at like the middle row, for example, 0 plus 1 equals 1, that was good. On the top row though, I have 2 plus 3x equals 35. If you add these, you're supposed to get a 35. Well, just do another quick problem. 2 plus 3x equals 35, and that's something you can solve really fast. You get x equals 11. And this final part right here, 9 plus 17 has to equal y plus 8. So I get 26 has to equal y plus 8, and then it's just a matter of solving that for y. Subtract the 8 from both sides, you get 18 for y.